Okay, so today we're talking about reflections, which means to flip. You've now taped in all of your orange arrows, and I've showed you how to flip it over the x-axis and flip it over the y-axis. Okay? Did your orange triangles change size when you flip them? No. That means that they're congruent shapes. Okay, there's also something called a line of symmetry. The line of symmetry of the first arrow was the x-axis, and the line of symmetry of the second one was the y-axis. Girls, you used to be really good at the line of symmetry because you took a sheet of paper and you folded it, and what did you cut out?
Heart.
A heart, right? So when I cut out that heart, why did you fold your paper in half?
Because that's a line of symmetry.
Good, because that's the line of symmetry because you wanted your heart to be the same on both sides, right? Now let's show your age here a second. Some of you also created your name monster when you were in elementary school. When you were learning to do cursive, if they even do that anymore. Okay, you wrote your name. And then they said, okay, now I want you to take your name. Uh-oh. And then they had you rotate, you had to like fold your paper in half. And then you had to make a monster out of it. Uh-oh. Sorry. And you had to make a monster out of it. And they told you to, and they told you to decorate it. So here's the eyes of your monster. And here's your monster's hands, maybe. And here's your monster's feet. Are you with me? You remember doing that?
No.
Okay, y'all are deprived. Maybe we'll have a project of it. But basically, what it's saying is this line right here is your line of symmetry, meaning it's the same on both sides. Huh? There's a line. There's an imaginary line. It's called the line of symmetry. Okay? You do that also when you make snowflakes. Remember you fold the paper all up, you make lots of little lines of symmetry, and you cut out the snowflake and open it back up, and isn't it pretty?
Yes.
Okay? So those are all lines of symmetry. Yesterday, we talked about orientation changes. Well, really what you wrote on your sticky note is that a translation has no orientation change. Today, I'm going to tell you that a reflection is the only transformation that has an orientation change. Ms. Ramsey, I still don't know what that means, but okay. I'm going to give you an example here in just a second, and you're going to go, oh, okay, now I get it. Okay? Translation, rotation, dilation do not have orientation changes. A reflection is the only one. Are we good? Okay, so let's take a look at our notes. Somebody remind me again, what is a pre-image?
The image before you make a copy.
Good, it's the one before you make a copy, it's your original. So I want you to take a second to go fill out the coordinates of my original shape right here. Okay, what'd you get for A? 1, 1. What'd you get for B? 4, 2. Very good. What'd you get for C? And D? -4, 5. Remember, right here it just says X and Y because we just took those points straight from the pictures. We just copied them straight over, right? Okay. Now, what does it want me to do? Reflect where? Okay, it tells me right here, reflect it across the x-axis. On reflections, you're not going to miss because it's hard. You're going to miss because you don't pay attention to what it's asking you to reflect over. So this one wants me to reflect over the x-axis. I expect you to write on your picture where you think that line is. Are you with me? It's not always going to be an axis, and we'll show you that in a minute. But right now it's saying to reflect it over the x-axis. This right now is my x-axis, correct? If I'm going to reflect over that line, okay, A is right here. It's 1 away from the line, so I need to go 1 down. That means this point right here is now my A prime. B is 2 away from the line, so I need to go 2 down. That point right there is now my B prime. C is 4 above the line, so I need to go down 4. That point right here becomes my C prime. And then D is, what is that, 5? So I need to go down 5 more. And that's going to be my D prime. Question, did this shape change size? Did the orientation change?
Yes.
What does that mean, Miss Ramsey? I don't understand.
The letters flip.
Okay, if I start at A and I go clockwise, on this one it's A, D, C, B. Would you agree? Down here, if I start at A and I go clockwise, then my letters are A prime, B prime, C prime, D prime. Are my letters exactly the same? No. That means my orientation changed. That means it has to be a reflection. If they're the same order, A, D, C, B, A, D, C, B, that means there is no orientation and it is not a reflection. Does that make sense? Okay. I want you to take a second and I want you to fill in these coordinates right here. Tell me what you get for A prime. 1, -1, B prime. 4, -2, C prime. And D prime. Huh. Did you see something? We did that the hard way to start with. But that's because we weren't sure what the pattern was. It only works with axis. So what did we find out? Tell me, what happened to my x-axis between my original and my, after I reflected it? It stayed the same. So if this one is x, that means the pattern for this one right here would also be x, right? So the other one, what happened to it? Change negative. Please don't think about changing to negative. I want you to think that it changed its sign. Okay? I want you to think of it as changing its sign, because if I would have translated from here up, it would have gone from a negative to a positive. So don't think of it as a negative. Even though right here I'm going to write negative y, if it would have started as a -3 right here, then over here it would have meant that it would have been a -3, which is really a +3. Okay? So I don't want you to think of it being a negative. I want you to think of it as changing the sign, opposite of whatever it is. So if I reflect over the x-axis, my y sign changes. Reflect over the x-axis, my y sign changes. Are you with me? So remind me again, what happens to the x coordinate if I flip over the x?
Stays the same.
Stays the same. Very good. And what happens to my y coordinate if I flip over the x? It changes the sign. And this next part right here is what we just talked about, the orientation, so we're good. So now I'm all about tricking you. Don't fall for my trick. I want you to attempt this next problem like what we just did. Don't fall for my trick. Be careful. Make sure you read. Tell me, what did you put for A? -7, 8? 8, right? That's okay. What's B? -3, 8. Very good. What about C? -1, 2. Very good. What about D? -7, 2. Very good. And I wrote X and Y because I just copied those from my picture, right? What did it ask me to do next? The y-axis. How many of you got the y-axis? That means they want you to reflect it over this line, right? If you reflected it down, you did it wrong. They want me to reflect it over the y-axis, so now I have to go to the other side of that line. So your new shape should have looked something like this. Is that true? Okay, so this would be my B prime, my A prime, my D prime, and my C prime. What'd you get for your coordinate for A prime? 7, 8, very good. What about B prime? Let me ask you a question. What quadrant is this in?
Positive. First quadrant.
It's the first quadrant. Aren't all of them supposed to be positive, positive?
Yes.
When you're doing reflections, if it's in a one particular quadrant, make sure all those are in that quadrant. All of these have to be the same. And what did we learn from the other one? When I reflected over the x, did the numbers change at all?
No, the sign.
We just flipped it. All that happened was our signs changed. So I'm sure right here, what should have happened? This should have been 3, 8, 1, 2, 7, 2. I'm in the first quadrant. These are all positive numbers, aren't they? So make sure that all of these are going to be positive numbers. What happened between my x values?
Became positive.
So this is our negative x. It just changed signs, right? It was negative, they became positive. And then what happened to the y's? Stayed the same, so it's just going to be a y. Are we okay? All right, so the x coordinate along the y-axis changed your sign. And your y coordinate along the y-axis stayed the same. Okay, flip it over to the back. Oh, an ambulance. So I went and bought some ambulances and I sent them off to be painted or wrapped or whatever they do nowadays. And they came back looking like this. They're supposed to be different. I wanted them designed different. I want to know, should I pay the bill or not? Why not?
It depends. Well, if you look at the
Look at that.
Look at the what?
Where it says ambulance.
Where it says ambulance. What about it?
Backwards.
Starts with an E. Ambulance doesn't start with an E.
it's so that when you're driving, you see it in mirrors.
Emergency right here starts with a Y. Have you ever looked in a mirror with your shirt? Your shirt looks just fine. You look in a mirror, what happened to it?
It's the opposite.
It's reversed, right? You can't read it, can you? Although you sat in the mirror one time, I know, and you were trying. That was junior high thing, right? Okay. Well, this is done properly because when I'm driving in my car and I look in my rearview mirror, okay, when I look in the mirror and I see the reflection, then I'd actually see the writing ambulance
Oh, they
or
actually do that?
emergency. Yes, it's a real thing.
Oh.
Most ambulances still do this. There are some that don't. I've seen some that didn't reverse it. Okay, because if I were deaf and I can't hear the sirens and I turn around and see in my rearview mirror, would I see that? And then my brain doesn't have to try and read it. Because you know, reading in your shirt in the back of the mirror, that's kind of hard sometimes. Even if you know what it says, right? So if I do this, then I don't have to think about it right away. Prime example of how we use reflections. Are we okay? Learned something new already today, right?
Yep.
Good. All right, so now let's look at 3 and 4. Oops, too far. Now, we will not always reflect over the x or the y axis. Right here, they want me to reflect point A, which is this one right here, but they want me to reflect it over the line x equals 1. You have a whole tab from last semester on equations that explains what x equals 1 looks like. I'm going to remind you the x value is 1. What's the y value? I don't care. Put whatever you want in there. It doesn't matter what you put. So I'm going to put 1, 2, and 3. So if I graph this, 1, 1, 1, 2, 1, 3, it means that this is the line I want to move that point over. So I have to move this point twice. So I need to move it over twice more. That means this point right here is my A prime. So my coordinate for A prime is -1, 1. Because remember, right here, my axis, right? Don't get tricked. There's my axis. So that point right there is at -1, 1. Same thing over here. This is y equals -1. What it means right here is that if I had 3 points, I want my y value to be a -1. What do I want my x's to be? Don't care. Put 1, 2, 3. So if I graphed over 1, down 1, over 2, down 1, over 3, down 1, that means this is the line I'm going to reflect over. I'm going to flip this point. I have to go 2 down to get to it. So I'm going to have to go 2 down more. That point right there would be my mid-coordinate. So my A prime, remember, here are my axis. So that point is at 1, 2, 3, 1, 2, 3, 3, -3. Are we okay?